Okay, let's have a look at question 4. So it says in the diagram, the circle centered at n, -1 and 3, passes through A, -1 and -1, and C. And then they give you that B is -4 and 2, and then C, D, and E are joined to form a parallelogram with such that BE is parallel to the x-axis, CD is the tangent to the circle at C, and CD is 6 units. Okay, and then they give you the picture there. So 4.1 says write down the length of the radius of the circle. Okay, so if you notice, just by looking at that circle there, you can see that N and A lie in the same line. Okay, they have the exact same x coordinate. Okay, so N is given as -1 and 3, and then let's see, A is given as -1 and -1. Okay, so if we take the change in the y, we'll get the radius there since N is the center of the circle. Okay, so therefore if you look at the change in y, it's equal to -1 minus 3, which equals to -4. Okay, so therefore the radius is always a positive value, which equals to 4 units. Okay, now 4.2.1 says the coordinate of C. Okay, so now we're looking for C. Okay, now one thing that we do know, it says at the top there that CD is tangent to the circle at C, which means at point C, if we're a tangent, okay, it means that my radius of the circle and the tangent's at 90 degrees. Okay, now by knowing that, we know then that C sits in the same line as N and A. Okay, so therefore, because CD is then parallel with CN, okay, and the radius is 4 units, so R we've just found to be 4, we can say that C will be -1, okay, same x coordinate as N, okay, and now it's going to be 3 units plus an additional 4 units, so therefore C is -1 and 7. Okay, now 4.2.2 asks you the coordinate of D. Okay, now D is perfectly in line with C, okay, plus we know that CD is 6 units and CD is parallel to the x-axis. Okay, this means that D will share the same y coordinate as C. Okay, so we've just found C to be -1 and 7. Therefore D is also going to have a y coordinate of 7 because they are in line. It's just that the x coordinate has moved 6 units to the right. Okay, so that's -1 plus 6, so therefore D is going to be 5 and 7. Okay, now 4.2.3 says the area of BCD. Okay, so I've drawn the triangle here. Okay, we've got now these values over here, that's 5 and 7. Okay, this one here I see is -1 and 7. Okay, now they want the area of the triangle. Now we know the formula for area of a triangle, okay, is given as a half base times height. So a half base times height. Okay, but that height needs to be the perpendicular height. But we don't have a perpendicular height, so we've got to construct a perpendicular height. Okay, now this perpendicular height here is going to be the difference in y value from B to C. Okay, so we can see that the y value for B is 2 and for C is 7. Therefore, the difference in height here is going to be 5 units. Okay, so therefore, if we find the area of triangle ACD, it's then going to be a half times my base. I'm going to use this top one up here, which is 6 units. We know that it was given to us. Okay, multiplied by 5 as my height, which then gives you 15 units squared. Remember, area is squared units. Okay, now 4.3 asks the following. The circle centered at N is reflected about the y-x line. M is the center of the new circle which is formed. Okay, these two circles intersect at A and F. Now they haven't indicated F on the diagram, as you can see there, but if we have a look here, when we reflect over the y equals to x line, okay, it's a 45 line. So if you have your axis there, we're reflecting over that line. What it's saying is my x value now becomes my new y value, and my y value now becomes my new x value because of them being equal to each other. So we saw that N was -1 and 3, Therefore, my x value is now going to become 3 and my y value is going to become -1. So therefore, M will have a coordinate of 3 and -1. Okay, now they want you to find the distance between M and N. Okay, so we're going to use our distance formula over here. Okay, so all we have to do is plug in the values. Okay, so if we plug in those values over there, we're going to get the following. We're going to get the distance of Mn is going to equal to the square root of 3 minus -1 squared plus -1 minus 3. And that's going to all be squared. Okay, if you plug that into your calculator, you get the square root of 32, and you can simplify that to 4 root 2, or you can put it in decimal points if you want. Okay, now the last one there, 4.3.2, says the midpoint of AF. Okay, now the important thing is you need to find out where where F is situated on the first circle. So I've redrawn this diagram over here. Okay, now we know that M is sitting at -3. Okay, let me just redo this. M is at 3 and -1. Okay, which means at this point here we're sitting at -1. Okay, and A is also at -1. Okay, so I haven't really drawn this to proportion, but we can see that if we go up with our radius, remember the radius for the circles need to be the same. So the radius for the second circle is still going to be 4 units. Okay, so if we go from -1 up 4 units, we're going to get to where y equals to 3, which means it's going to be in line with the center of the other circle. Okay, and then this one will line up over there. So you can see, okay, I haven't really drawn this properly, but the centers and F and A need to form a square. Okay, if you link them all together with 90-degree angles, but mine's not really drawn to scale here, but this is what I'm trying to show you. So F is over there, A is over there, and now we want the midpoint between these two. But you can see that we're drawing a perfect square over there. Okay, which means we can then just use the midpoint theorem of a line. Okay, so if we use the midpoint theorem of a line, okay, the reason why I'm saying draw the square is so that you can find that F coordinate. So F should be intersecting at where y is 3, because it should be in line with the center of N, and it should be in line with M. Okay, so what we technically have here is this circle and this circle over here. There's the center, it's lining up there. There's the center, it's lining up there. Okay, that's A, and then there's the center, so there's A and F. Okay, and this needs to, or we know that this is at -1 and 3, so F also needs to be a y coordinate of 3, and we know that this coordinate M here was 3 and -1, so therefore the x coordinate for F also needs to be 3. Okay, sometimes you just need to draw these out. Okay, so now if you want to find the midpoint of F and A, we have the two coordinates, so F is going to be 3 and 3. Okay, and then A is then going to be given as, what was A given as? -1 and -1. Okay, so now just to find the midpoint, we'll have x1 plus x2 divided by 2, and then we'll have y1 plus y2 divided by 2. Okay, and if we plug in those values, we're going to have -1 plus 3, and we'll have -1 plus 3. Both of them are divided by 2, which means our midpoint is going to be at the coordinate 1 and 1. Okay, and that's how we go about doing this question. Okay, hope you guys found this maths video helpful. Okay, don't be scared to draw on your papers as well. It is your paper, so in your finals, draw on them, draw that second circle so you understand what's happening. Okay, if you are enjoying the content, then please leave a thumbs up on the video. If you have any questions regarding this question, leave them in the comment section down below. I'll get back to them as soon as I can. And remember, it's never too late to have an OIC moment.